In this video, we're going to talk about tests for symmetry. Let's take a look at this graph right here. First of all, this model is not a function because it does not pass the vertical line test. However, this graph is symmetric with respect to the x-axis because if you fold along the x-axis, this graph will overlap one another. Also, look at the y values. If x, y is on the graph, then the opposite of y, which is negative y, x negative y, will also be on the graph. Algebraically, if you replace y with negative y, you still have the same equation. Now let's take a look at this graph. This graph is a parabola. It passes a vertical line test. And it is symmetric with respect to the y-axis. Because if you fold, pretend this is a paper, and if you fold along the y-axis, this graph will overlap one another. So when the graph is symmetric with respect to the y-axis, now notice y value is same, but x are the opposite. So if you have xy, that means negative xy will also be on the graph on the other side. Algebraically, if you replace x with negative x, you will still get the same equation. Now, let's look at this graph. This graph, we call it, by the way, this is also a function. It passes the vertical line test. This is symmetric with respect to the origin. Origin is 0, 0. In order for that to happen, you have to fold it twice. You have to fold it along the y-axis first, and then the x-axis. Then the graph will overlap. Or you could fold it along the x-axis first, and fold it along the y-axis. In this case, if you have x comma y, that means opposite of x and opposite of y will be on the graph. Algebraically, replacing x with negative x and y with negative y will produce the same equations. Let's see some examples. If you look at this example, the graph x minus y squared equals 1. This is not a function. However, this graph looks like symmetric with respect to the x-axis because if you fold it along the x-axis, the graphs will overlap. And also, if that is true, if x, y is on the graph, that means if it's symmetric to the x-axis, that means x comma negative y should also be on the graph. So let's take a look at it. Let's see what happens numerically. If x equals 10, you get 10 minus y squared equals 1. Therefore, you get 9 equals y squared. And you know that y is positive negative radical 9, which means it's gonna be positive negative 3. So therefore, when you x equals 10, you're going to get positive 3 and also negative 3. So numerically, we supported that this is symmetric with respect to the x-axis. What about algebraically? Well, you got x minus y squared equals 1. If you plug in negative y instead of y, you still need to get the same equation. Let's see if that happens. So instead of y, I'm plugging in negative y. What is quantity negative y squared? You still get y squared. So notice, even though you plug in negative y, you still ended up with the same equation. So therefore, this graph is symmetric with respect to the x-axis. Now let's take a look at this example. You got x, y equals 4. So when you graph it, you get something like this. Now, this graph is not symmetric with respect to the x-axis, nor is it symmetric to the y-axis. But it is symmetric with respect to the origin because when you fold it along the y-axis and then fold it along the x-axis, the graphs will overlap. Which means when you have x comma y on the graph, that means you are also going to have negative x comma negative y on the graph. So since you have x, y equals 4, you know that 2 times 2 is 4, so you could say 2 comma 2. That means negative 2, opposite of x, negative 2, opposite of y, negative 2 should also be on the graph. Is it? Negative 2 times negative 2 is 4. So numerically, we just supported that this is respect to the symmetric respect to the origin. What about algebraically? Let's plug in, you got x, y equals 4. Let's see what happens when you plug in negative x for x and negative y for y. Do we still get the same equation? We do. So algebraically, we just show that this graph is symmetric with respect to the origin. Numerically, we also show that graph is symmetry with respect to the origin. Now let's look at these two examples. This first example looks like it's symmetric with respect to the y-axis. In order for that to happen, when you have x comma y on the graph, you should also have negative x comma y. So that means, let's say, when x equals 2, when x equals 2, plug in 2 right here, and you get 2. So does that mean opposite of that, which is negative 2? Is negative 2 comma 2 also on the graph? Well, let's plug it in and see what happens. What is y equals negative times negative 2 squared plus 6? We end up getting negative 2 squared is 4, so negative 4 plus 6 is 2. So we indeed get, when you plug in negative 2, you also get 2. So numerically, we just supported that 2, 2, negative 2, 2 is, they are both on the graph. What about algebraically? Let's see what happens when you plug in negative x instead of x and see if you still get the same equation. Well, when you square negative x, you get x squared, and that negative is already outside. So I still get y equals negative x squared plus 6. So we just showed that this graph is symmetric with respect to the y-axis. Let's take a look at this example. X squared plus y squared equals 25 is a circle with a radius of 5 and center at the origin, 0, 0. Now, this graph looks like it is symmetric with respect to the y-axis, x-axis, and also symmetric with respect to the origin. So it qualifies all three of them. But let's check. First, symmetry with respect to the y-axis. If x comma y is on the graph, if it's symmetric to the y-axis, that means negative x comma y should also be on the graph, right? So let's plug in negative x comma y and see if we get the same equation. So you end up getting x squared plus y squared equals 25. So it is symmetry with respect to the y-axis. What about x-axis? If x comma y is on the graph, that means x comma negative y should also be on the graph. So instead of y, let's plug in negative y and see what happens. We still get x squared plus y squared equals 25. What about to the origin? Symmetry with respect to the origin. If you have x comma y, that means you should also have negative x comma negative y. So let's substitute negative x and negative y and see if you get the same equation. You did. So it is indeed symmetry with respect to the origin. Now we're going to talk about even and odd functions. Functions that are symmetric with respect to the y-axis are called even functions. When a function is even, when you plug in negative x instead of x, you still get the same equation. Functions that are symmetric with respect to the origins are odd functions. When function is odd functions, when you plug in negative x instead of x, you'll get negative f of x. And we'll look at some examples. But notice, we're not talking about any symmetry with respect to the x-axis because they're not functions. Only graphs that are symmetric with respect to the y and origin are functions. We have f of x equals x cubed minus 2x. And you may use your graphing calculator to graph this, and you'll get something like this graph over here. Now we have to determine whether this is odd or even function. Well, it looks like this graph is symmetric with respect to the origin because you have to fold it twice for their graphs, the graphs to overlap one another. Well, let's check algebraically. So what happens if function is odd? When you plug in negative x instead of x, you need to get negative f of x. So let's see what happens. Let's plug in negative x instead of x. And you will get negative x cubed plus 2x. Now, is this, remember, if you take out negative, you get quantity x cubed minus 2x. And notice, this is exactly the opposite of this right here. So we do indeed get negative f of x. Therefore, we showed that this is an odd function. Since when we plug in negative x instead of x, we got opposite of f of x. And we got h of x equals x cubed minus 0.5 x squared minus 3. Now, is this even or odd function? Well, when you graph this function using your graphing calculator, it looks like this is odd function. But we have to double check algebraically. So if you put negative x instead of x, you need to get negative h of x. Let's see what happens. So let's plug in negative x instead of x. So when you simplify this, you're going to get negative x cubed. When you square that, you get a positive x squared, and you already have negative. So it's negative 0.5 x squared minus 3. Now, when you take out the negative, you get x cubed plus 0.5 x squared plus 3. Is this opposite of this? It's not. In other words, when you multiply everything by negative here, when you multiply everything by negative, do you get this? No. So this is false. This is not true. Therefore, this function is neither even or odd. Now let's take a look at our final example. You got g of x equals x to the fourth plus 2. Now this looks like an even function because when the graph looks symmetric with respect to the y-axis. So algebraically, what needs to happen is that when you plug in negative x instead of x, that should be the same thing as g of x. If this is true, then g of x is even. So let's plug it in, negative x. And what's negative x to the fourth power? It's x to the 4. So indeed, these two are equivalent. So g of x is even function.